Thank you for taking the time to view my slideshow video. I'll be presenting to you today climate and Vibrio cholera. I will be looking at the effects of climate change on the frequency and distribution of cholera outbreaks all over the world. Just to give a quick definition of cholera, it is a waterborne diarrheal disease which infects humans and is caused by the bacterium V. cholerae. It can lead to death in healthy young individuals in a matter of a few hours. It is caused by ingestion of this bacterium, and transmission occurs through direct fecal-oral contamination or through ingestion of contaminated water or food. According to the World Health Organization, the disease is characterized in its most severe form by a sudden onset of acute watery diarrhea that can lead to death by severe dehydration and kidney failure. It is also important to note that there's a very short incubation period, 2 hours to 5 days, that enhances the potentially explosive pattern of outbreaks as the number of cases can rise very quickly. To show you a quick outline, we'll be going over a brief history of cholera, a look at the transmission of V. cholera, a look at the climate dependence of cholera, cholera and ENSO, and the possibility of climate change as a proxy to predict cholera outbreaks in the future. To start off, we'll be looking at past history of cholera. Throughout history, there have been cholera-like illnesses that have existed for the past millennia, or the past 2 millennia. However, these were not classified as cholera outbreaks, so a widely agreed upon date of the first cholera outbreak, or the first cholera pandemic, was 1817. After the first pandemic, which was one of extreme virulence, there were 6 more, including the 7th pandemic, which we are currently in. The second pandemic began in 1832 and was marked by a much wider spread. It had gained global dominance. The third pandemic began in 1852 and was marked by a very high death rate. This third pandemic was also marked by a medical event in Britain, where the Queen's physician stumbled upon a great idea. He realized that there was a link between the water supply and the prevalence of cholera cases. The fourth pandemic of cholera began in 1863, and by 1865 had reached Mecca. Unfortunately, this was a time during great celebration, so many of the people who had visited, or the pilgrims who had made the pilgrimage to Mecca, then returned home afterwards, bringing the disease with them. The fifth pandemic was one that was marked by being not as deadly, began in 1883, and it was obviously less devastating. And the sixth cholera pandemic began in the year 1889, and is well known for its rampant transmission in India, where over 800,000 people died there alone. According to the World Health Organization, we are presently in the 7th pandemic of cholera, which started in 1961. We will now take a break away from the history lesson and lean more in towards the transmission of V. cholera, as in how does it travel from host to host. We'll look at the transmission of cholera based on the effects of global climate on infectious diseases by Lip et al. When looking at the transmission of cholera, it's pretty much a bottom-up approach. You start at the bottom of the triangle, or the inverted triangle, which is the abiotic factors. These include temperature, pH, salinity, and sunlight. The next section up, you have phytoplankton and aquatic plants. The algae promote the survival of the V. cholera and provide food for the zooplankton. The top part of an inverted triangle is zooplankton itself. V. cholera proliferate in association with a commensal relationship with the zooplankton. Next, we'll be looking at the climate dependence of cholera, as in if Vibrio cholera has any specific climate that it thrives in, as opposed to any climate that it cannot survive in. Luckily, because cholera has been such a prevalent disease for the past 200 years, it has allowed scientists to have time studies where they look at, a series of temperatures over the last however many years, and they also look at the outbreaks of cholera over the same amount of years. In looking at the climate dependence of cholera, it's always a good idea to look at a case study. This study was performed by Caldwell in 1996, and she looked at the relationship between sea surface temperatures and the cholera case data in Bangladesh from January to December in 1994. Now, as you can see on the left-hand side, cholera is in a percentage, and on the right-hand side, temperature is in degrees Celsius. It is seen that throughout the year, as the temperature is increasing, so is the percentage of cholera outbreaks. So if you look at May, it looks as if the temperature is reaching about 28 degrees, and the cholera percentage has now reached up to probably about 28-29%. After the high in May, the temperature goes down to about 26 or 27 degrees from about May until September, the end of May until the end of September, and you start to see a decrease in cholera outbreaks as well. Looking at this statistically significant data, it does show that as temperature changes or as temperature increases, the cases of cholera increase, and as temperature decreases, the cases of cholera decrease. This would definitely point out a temperature dependence of cholera, and which would lead to a climate dependence of cholera. Next, we will be viewing the mechanics of ENSO and looking at how it affects the distribution and abundance of cholera. To begin, ENSO stands for the El Niño Southern Oscillation. Now, originally, it was seen as two separate weather phenomena, where El Niño has been accredited with an increase in heavy rainfall, which usually leads to flooding. It has an increased rainfall and warms the temperatures a little bit of the sea surface. And the second weather event that they thought was a separate weather event was the Southern Oscillation, which is actually a fluctuation in the atmospheric pressure between Tahiti and Australia. This weather event has been accredited for increasing rains in India. So viewing the weather phenomenon as a single entity, it is shown that ENSO has increased rainfall and also has increased the sea surface temperature. Looking at the map in front of you, it is from a study by Pascal et al., where they looked at the correlations between September cholera cases and the January sea surface temperatures, which were the anomalies in a global ocean grid. Now, the black line that you see separating the two colors is something that indicates a 90-degree significance level, which is, as we all know, a very significant correlation. Importantly to note that a region of significant rank correlation emerges in the Pacific Ocean, which has a bunch of black lines around it, that corresponds geographically with the pattern of warming observed during El Niño events, which thus would suggest that as these El Niño events are happening, the higher the correlation is between sea surface temperatures and cholera outbreaks. This would then lead to the inevitable questions of, is there a possibility of using climate change as a proxy or a predictor of cholera outbreaks? As in, can we use ENSO as a predictor of sea surface temperatures, which can then be used as a predictor of cholera outbreaks? The World Health Organization sure did believe so. They made a map which estimated the mortality per million people attributed to climate change by the year 2000, using information from 1960 to 1990 on levels of greenhouse gases and the associated climate change. The green estimates 0 to 2 people per million, yellow is 2 to 4, orange is 4 to 70, red is 70 to 120. Using a similar sort of map, the author Patz used a quantitative study of climate health relationships and to estimate relative changes in a range of climate-sensitive health outcomes, including cardiovascular disease, diarrhea, malaria, inland and coastal flooding, and malnutrition for the years 2000 to 2030. The important point to take home is that the World Health Organization, as well as scientists all over the world, are in fact using anthropogenic climate change to determine the effectiveness of different diseases. So yes, we can in fact use ENSO to determine the future sea surface temperatures, to determine future outbreaks of cholera, looking at how deadly they will be, how prevalent, and how widely distributed. Thank you so much for listening to my video on climate change and cholera.